This logs are what? It starts with an E. Exponents, okay? Logs are exponents. So you're going to find that you actually, these properties are going to kind of make sense if you go back to chapter 2 and think about those properties of exponents that we learned. Do y'all know what I'm talking about? Power of a product, power of a quotient, quotient of a product, quotient of power. All right. So remember though, whenever we're doing things like multiplying like this, the stipulation is before I can combine them that the base has to be the same, right? Yeah. That's going to be the same with a lot of your log properties, okay? And as opposed to 7 properties, there are 3 properties. Y'all ready?
Addition.
The first one is called the product property. This product property. Product means what? Multiply. So, let's say, actually, I'm gonna change this to a log base B. Of 2 things multiplied together. So these are both hooked with the log. Now, if you're multiplying with the same base and think in terms of exponents, what do you do with those exponents? Add them. So this I can split up as the log base B of M plus the log base B of N. If I go from left to right, it's called expanding. And if I go from right to left, it's called condensing. I always think about Campbell's soup when I think about that. Why? Because, you know, like Campbell's soup is condensed soup. You have to add water to it. You're supposed to.
It just makes me hungry.
All right, so this could be quite convenient if, let's say, you knew what this equaled and what this equaled. You could find out what it equaled together here. For example, let's say I knew that, let me get one so I'm not lying, that the log base 4 of 3 was approximately 0.792. And I knew that the log base 4 of 7 was approximately 1.404. Then if I want to know what is the log base 4 of 21,
You multiply that.
7 times 3 is 21. Do we agree?
Yeah.
But that's not the same thing as saying these 2 things multiplied together. Right? Because I'm just multiplying these numbers. They're both hooked. But by that product property, I can say that this is the same thing. I can expand it out a little bit. This way.
So 7 and 3 equals, right?
Say that again.
Log 4, 7 times 3 will work.
Yes. It's rewritten. What I did, I just rewrote this using multiplication since I was given these 2 things. So now I could say, well, I know what each one of those are, so if I just add them together, it would tell me what log base 4 of 21 is. Does that make sense? Or am I kind of talking in circles? Okay, y'all sure?
Just add them?
I did. I related that number, that 21, I related it back to these 2 that I started with by multiplication because 3 times 7 is 21. What if I gave you this and I asked you what is log base 4 of 9?
Only take 3 and you multiply.
So that's the same thing as log base 4 of 3 times 3. Right? And now I can split those 2 up.
Log 4, 3
You see? We're just relating these numbers back to...
792 plus 1.
Which is, I don't know. 4, 18, carry 1, 1.54584. The point is that I'm manipulating these a little bit so that I can use this property to rewrite it a different way, to estimate its value. Since y'all don't know how to put anything right now, or I haven't taught you right now how to put anything in other than base 10 or natural log. So good? All right, property number 2 is the quotient property. Again, the key here, same base, okay? Quotient means to what? Divide. If you are dividing with the same base, what do you do with the exponents? Subtract them. So if you're talking about logs, since logs are exponents, I can break this up. Makes sense, right? Is it following logically for you a little bit why we're doing, if logs are exponents, then they should share the same properties, and they do. So let's take that same log base 3 and log base, oh, and by the way, this.
So if you divide it, then you subtract it, and if you multiply it, you add it.
Correct. And after we get through this initial part, we're going to really work to expand and condense some different logarithms. See how I go from a small version here, like it's condensed, it's all simplified, to it's expanded out. Really, expansion and condensing we do a lot whenever there's variables in there and stuff instead of numbers. You'll see. I'll do several examples. I just want you to know which way is expanding and which way is condensing.
To the right.
All right, let's take those same log base 3 and log base 7. And let's do log base 4 of 7/3.
So we're not going to do 3 and 4, 7.
What?
Are we going to keep the 3 and the 7?
No, because we don't know what that equals. We're going to use these that are given to us to estimate what this is. So how could I split this up? Log base 4 of 7 minus log base 4 of 3. Log base 4 of 7 is 1.404 minus 0.792. Which is what? Somebody with a 0.612. Thank you. Let's see if you really understand.
Would this be a negative number?
Hold on. Let me wait until I give you the last property before I do this. Then we'll combine
What's
them.
the last one? Addition.
I think I understand.
You think you'll understand it?
Try it.
Okay.
I swear that that'd be bad.
So this is different.
This is another problem right here? Or this is another thing?
Estimate using the numbers that you have. Estimate what that may equal. Tanner said y'all got this. So remember, so far I've learned about multiplication and division. So I need to express this number using only multiplication and division of 3 and 7.
So basically, you can square root both of them. That's what.
I see the wheels turning. Big wheels keep on turning. We are basically expanding this thing out as far as we can. Did anyone get to this point? Good, 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 good. I'm going to guess if you did not, it's because you didn't keep your numerator and denominator separate like you probably should have. But notice how we're integrating two properties here and not just one. Here's the quotient property. Here's the product property.
I got a negative number.
That's fine.
I kind of divided it.
And I don't know what that comes out to be on your calculator.
I got it then. I just didn't write it all out like that.
But you got it? No, if you got it. Does that make sense to everybody? And that's kind of a complicated one, yeah.
I get
Wait,
Tell me
what were you saying?
one more property. What?
Do that.
All right. The last one is the power product. Ah, property.
power property.
All right, so what this does, I'm raising something to a power. Now, if logs are exponents, so I've got an exponent that I'm raising to another power, what do?
Multiply it by itself.
Multiply it. So here, I'm going to bring this exponent around front and multiply. This is everybody's favorite log property.
Why?
It's easy.
So basically, you're just bringing the exponent.
Expand. Well, if you think about, like, go back and look at that 9 and 49 one that we did. So we had log base 4 of 9 over 49. We could have made this a lot simpler if we'd done log base 4 of 3 squared over 7 squared. So that when we subtracted minus log base 4 of 7 squared, instead of adding them twice, we could have just said that's 2 times log base 4 of 3 minus 2 log base 4 of 7. Get the same thing.
Itself 2 times.
Right, which is the same thing we did. We just did it as 3 times 3 instead of the 2 in front. Yeah, a little bit faster.
Should we write that down?
Yes, this is a cheetah problem. Yeah,
Yeah.
yeah. And let's do an expansion problem. Now, just like exponents, there's not a particular order of operations that we need to do this. We just need to make sure that we follow follow properties, and make sure if there are things that are in a fraction that the top stays together, the bottom stays together, and so forth.
How did we finish the power property?
That was it.
Oh,
It just multiplies around front. All right, so expanding is where we're taking those properties and we're moving left to right, okay? We're writing this out in as many separate pieces as we can. In general, each thing in here is going to have its own separate piece in the expression, okay? So I want to look and see what I can split up, break up, or do to expand this out. So what do you think we could do first? What do you see?
Pull the 3 down.
Well, is the 3 hooked to the 5x or is it hooked to the x?
It's hooked to the X.
It's only hooked to the x, okay? So be careful.
Multiply x 3 times?
You could write it that way, but we're going to be even a little,
Easy.
yeah. We're talking about taking one of those products and one of those properties and moving left to right with it for expansion. Which property do you see that you could use here? Okay, but that's only, if I put 3 to the front right now, then that's going to make it apply to all of this. Quotient. If you ever see a fraction, probably good to go ahead and split it up. So I've got the top minus the bottom. Does that confuse anybody?
Because minus and divided will be the same.
Correct. All right, so this last piece here, there's nothing else I can do to break that up. It's just a y there. I can't break y up any more than what it is. So I'm going to leave it alone, but I'm going to come over here and look at this one. What do you see that I could do?
All right.
All right, a lot of you are saying about the 3, but here's the difference. Understand that this and this are different. Do you see why? I need to break apart the multiplication first, because if I pull the 3 around front here, what's going to happen is it's going to the 5 also, but it can't go to the 5. So I need to split that up first. Exactly, add. So I got log 6 of 5 plus log 6 of x cubed minus log 6 of y. Now what can I do? Now do the 3. I told y'all everybody's favorite property is that exponent. Everybody wants to do it first every time. So now this can come around front. And now it's completely expanded. And it's completely expanded because each piece has one thing here. Each term in my expression. Does that make sense?
Yeah.
A little bit?
Perfect.
You sure?
Yes.
Circle it.
Perfect.
No, I don't need to circle. I know the last thing I write is this.
Do another one?
No,
No, we're good.
What?
Yeah, we're gonna go home. I can get done.
It's not going to make you go home any sooner.
I know, but I want to do home once I get out there. So I can have a cheetah after this.
Oh, I see what you're saying. Let me do one more
I'm
expansion.
going running after school. Me and Landon at the track. You cheetah.
I'm going to make this one kind of hard. Because I'm mean.
You right.
Thanks, Tanner. Appreciate that. What should I do first?
Move the division.
Division.
Subtract it.
Subtraction.
Log 7 3x squared minus log 7 5y 2/3.
Notice the parentheses here. What's wrong? Yes, this one, because the parentheses make it to everything, this one I'm going to move first, but this one I can't yet because the 2's only hooked to the x. Here is hooked to everything. Do you see the difference there?
Yeah, I see.
So this one, and be careful because I'm subtracting all of this. So whenever I start splitting up, I'm going to have to take that into account. All right, so here, what can we do with those two? I can add them. I can go ahead and split that up with adding. Of 3 plus log base 7x squared minus, and we said we can bring that 3 on around front.
You could add right?
I could. But be careful. Whenever you do this, this 3 is going to both of these. So when you do that,
Can we just do that? Right?
yes, you want to bring that 2 around now?
Yeah. Oh, can we?
Yes.
Good.
Tanner wanted to go ahead and bring that 2 around so he didn't have to write this whole expression again. He's ready to circle it. When you do this, yes, you split this up and you add. But if I'm not careful, number 1, this is telling me that the 3 only goes with the first one. And that's not true. It's got to go with both, right? And number 2, it's telling me I'm only dividing this one and this one I'm multiplying. So to solve that, I can put it in parentheses. So I know that I'm dividing by everything after that subtraction sign. Does that make sense?
Mm-hmm.
That was a tough one.
Circle it.
Circle it. See why they call it expansion? Look at what we started with and what we ended up with. Wow.
Exactly.
Expanding it out, because sometimes you know things that will help you simplify. Like maybe I know the log base 7 of 5, or maybe I know log base 7 of 3. All right. Let's condense. Condense, I will tell you, is a little bit different. Do your parentheses first always, okay? And move left to right as you do it. Left to right. All right. Maybe I should write that. Condense, parentheses first, then left to right. So,
Honestly, you missing a lot of phones today. This is the sentence. Man,
wow, way to throw him under the bus.
nah, that's how you do me all the time. You missing number 3. You know.
All right, so on this one, I'm not seeing any parentheses, which means I'm good just to go ahead and move left to right. And actually, I should put in here parentheses first, then I need to do exponents, then left to right. What do you see here that I can do first? The exponent.
My dad.
All right, so I'm going to do log 9 plus log, what is 2 to the 3rd power? Somebody said it. 8. Now left to right.
So you have to make the 3 become the 3rd power.
Yes. If I'm adding, that means I do what? Multiply.
Wait, how did you get A?
2 to the 3rd power.
Okay. So now we just kind of like.
Now we're moving left to right. So if I'm adding, by the way, I don't see a base indicated here. What does that mean? 10. 10, exactly. 10. 9 times 8 is?
72, I think.
You right. When I'm subtracting, I do what?
5.
I get log 2 and E4. Does that make sense?
Yeah.
Condensing is generally a little easier than logs, I think. I mean, expanding. I think.
A lot easier.
Circle it.
Circle it.
Oh, please.
One day I'm just going to show up at your house and scream, circle it. And see what we
Let me show you one little thing on your calculator if you'll take that out real quick. I told you that your calculator only does base of 10 and natural logs, and I'm not lying, it does. There's a way you can put these things in your calculator.
It just says log.
And let me use something that you know. You know that that should equal what? 3, because 2 to the third power is 8, right? We can use what we call a change of base.
Wait, is it supposed to be to the third power?
No, I'm telling you, we know that that equals 3. But there's not a way to put that in your calculator. But logs have this special property. In that if you do log, and it doesn't matter what this base is down here, and since your calculator does a base of 10, I'm going to make it base 10. Of 8 divided by log same base of 2, it will tell you what this equals. So try it on your calculator. Since your calculator will do a log base 10, do log 8 divided by log 2 and see what you get.
Well, I got 3.
Did you get it?
3.
Close your parentheses after this 8 here. It's here.
Yeah.
Okay, that's called a change of base. It doesn't matter what that base is as long as it's the same. Okay, so whereas before I was telling you evaluate without a calculator, because there's going to be sections on your test where I give you something like this and I say evaluate without a calculator. And I really just want you to know, could you check it on your calculator? Sure. You could do log 8 divided by log 2. You can't do the subscripts. Your log is only a base 10. But what you can do, as long as these bases are the same, you can evaluate this one this
Why is there
way.
a button that's called log base?
What?
There's a button that's called log base.
Where?
Nah.
You see that?
Log base. Log base.
You know young boy on the 18th.
Oh, you got a fancy calculator that'll let you put the base in there.
You do not look that young.
Yeah.
All right.
There's
Questions?
Graphs though.